of what is the best in class of business at that point in time. The framework, a lot of those are still valid, and you'll see that throughout this presentation I'm going to make reference to some of those things. But the steady state picture of business that I learned was swept away almost as soon as they handed me my diploma. And so let's look at how the main sources of competitive advantage have evolved over that period of time. So it used to be that the way that you would build a major corporation was by getting economies of scale, making more stuff to get a lower marginal cost of production. And then, we figured out, hey, in addition to that, can we get proprietary processes, ways that are unique to us that we can use to juice even more stuff to increase those economies of scale and then reduce the marginal cost of production. And then there was a guy named Bill Gates, maybe you've heard of him, who had a brilliant idea, among other people, that what is this marginal cost good for anyway? Why do we need it? Why can't we just create things that have a zero marginal cost of production, like software or proprietary algorithms? And so that was the next layer that was added on top of all these things. But guess what? That's last year's battle. These are now table stakes. They are not differentiators anymore. The new source of competitive advantage, at least for the next 5 to 10 years, and that's as far out as I'm confident enough to predict, is going to be proprietary, labeled, input-output data sets. Now think about it. Why is it that companies like Google or Facebook or any of the other giants that you think about in machine learning would give away all of their frameworks, would give away all of what you think, wait, why don't you hold on to that stuff? Well, if they're giving it away, that must not be the source of competitive advantage. What is the source of competitive advantage is that unique defensible data set that they can use to train that algorithm. And of course, as we're going to get to later on, that's not enough. You also have to have a way to ingest a lot more data to continue refining it. These things are not steady state, they're always evolving. But I've heard a lot of people talk about AI as being a force that's just going to sweep away all the old models of what it meant to compete. I respectfully disagree. I think that AI is simply going to be an accelerant, if we think about it strategically, for those old sources of competitive advantage. And it will do so along a parabolic curve. Effectively, if you are an early mover on these things, your competition is not going to be able to catch up. Yes, there's a point up here where everything levels out, but by the time your competitors get there, they'll be broke. So we don't even have to worry about that. All right, so first of all, let's step back and think about how do we think about data to begin with. All right, I'm going to ask for another hand raiser. How many people have heard the phrase, data is the new oil?
Yeah.
All right, so we're not at the Global Living Under a Rock conference. I'm so glad to hear that. Great guys. So that is a useful analogy, but it is not 100% apt. So what I'm going to do is here's how it's useful. Oil certainly was the power source behind the old industrial economy. And data certainly is the lubricant and the power source behind the digital economy. Okay, check. That makes sense. Now, oil must be refined to be useful, and so must data. I don't think I have to explain to the data scientists in the room what that means. But here's the thing. If data is the new oil, then we're in the age of kerosene. So let's rewind back to when we had just discovered oil, which you might be surprised to believe was actually about 5,000 or so years ago. The Mesopotamians used bitumen as the mortar within their ziggurats. The Romans saw this stuff bubbling up from the ground in Caledonia, but they largely used it for lubricant, or as you saw in the Mesopotamian situation, to stick stuff together. It was only when we had a refining process that made something useful out of this, in this case kerosene, that oil began to be valuable. What they used kerosene for was to light the world. Before kerosene came along, you basically used tallow, animal fat, it stank, it produced an ugly yellow flame. Kerosene had no smell, it was bright white, and it promised to revolutionize the world at that time. Now, John Rockefeller saw that, hey, I see this as valuable, but this refining process is only going to get better. And if we're able to further refine oil into things that are even more useful than kerosene, the value of oil is going to skyrocket. So quite intelligently, he cornered the market on oil. And in doing so, he became one of the richest men to ever live. So you might also figure out that a lot of the great tech leaders today have had that same insight about data. The refining process, artificial intelligence, is only going to get better. And the better it gets, the more valuable this becomes. So many of these companies have said, how can I collect and sit on top of the world's most valuable data? Now, but there's a difference between oil and data, and this is where the metaphor completely falls apart. Oil is what economists call a rival good. If you have it, then I can't. So if I drink your milkshake, to use the there will be blood slogan, then it's gone. There is no more milkshake, you can't have it, neither can I, it's disappeared. Data, however, is a non-rival good. You can have it, and I can have it. You can all have it, as so far as I'm concerned. The question is, how do you go out and get it? So what this means is, practically, the data hoarders of today are not necessarily tomorrow's winners. They have a pretty good head start, but there are room for people who want to move within this space. It means that we need to find ways to collect valuable data they don't have and they cannot get. So let's take another lens on this. Let's look at AI from an economics perspective. There was a great book that came out called Prediction Machines by Jay Agrawal and a number of other co-authors. I'm not going to dwell too much time on this because you can read the book, you can watch the YouTube lectures, they're really great. But we always want to think of technology in an economics context. So what does AI do fundamentally in terms of raising and lowering costs? It lowers the cost of prediction and pattern recognition. Now, Ajay would say that it's just prediction, hence, his book Prediction Machines. And yes, I get that the math fundamentally says for any given variable X, predict Y. But I insert the term pattern recognition simply because human beings don't think in math, we think in metaphors. And the metaphors that we use to analyze a problem are quite important. So what does that do? If the cost of prediction is lowered, that means that any activity we currently do now with prediction or frame as a prediction problem, we're going to do more of because it's cheaper. It also means that the cost of substitutes decreases. I put this wrong, and the cost of complements increase. So think about it like this: if the cost of coffee falls, a lot of us are going to be drinking a lot more coffee. If we're drinking more coffee, then necessarily we're drinking less tea, which is a substitute for coffee. Tea's got to get cheaper to keep up. But what's also going to happen is, think about cream and sugar. Those are complements to both tea and coffee. If we're drinking a lot more coffee, people are going to be buying a lot more cream, buying a lot more sugar. There's more demand, price goes up. But here's the thing, and this is probably the more interesting piece of it, we can also reframe problems to be about prediction and pattern recognition that simply were not before. This is sort of the joker in the hole. How can, and I'll be getting to an example of this later, and many of you are probably more advanced in this than I am. So, 3 questions to ask yourself about this. So, if that's what it's all about, you've got to think, where are the most costly areas of uncertainty within my business? You need to think about big areas of uncertainty and small areas of uncertainty. Now, this can be things like, when is the truck going to arrive? How long is it going to be till this piece of machine breaks? Or it could be, how do I better forecast aggregate demand? That's your question to solve, not mine. Also, the question is, what could be possible if I could reduce that uncertainty, and critically, how much do I have to reduce it by? So, for instance, I think Ajay gives, who's the author of that book, gives a great example of saying, what would Amazon do if it knew that exactly what you were going to buy? It could just send things right to your doorstep, technically speaking, and then you could ship back whatever you didn't end up wanting. To do that, it only has to be, maybe 80% accurate, because it can absorb those costs. But there are other issues where you might need to be 6 Sigma accurate in order to make this a viable approach. And then getting a little bit more technical, more lower in the weeds, how much of the current workflow of my business relies on pattern recognition or simple predictions. And so this involves you taking your existing workflows, breaking them down into as many subcomponents as you can, and identifying where and how prediction and pattern recognition come in, the extent to which those things are replaceable or supplementable through artificial and machine intelligence, and then thinking about ways you can reinvent your processes. So now we're going to look at the prism from a slightly different angle. So this is one of the more famous models in business. It's called Porter's 5 Forces. It was created by a gentleman named Michael Porter, who was one of the leading lights out of Harvard Business School. And this basically defines, what are the forces that make a space competitive or uncompetitive. And the threat of new entrants, the bargaining power of suppliers, the bargaining power of buyers, and the threat of substitute products all converge in that center to define what is the rivalry among existing competitors. And so within that broader context that we looked about AI before, let's look at each of these and see how that might transform any given space. So first of all, let's think about supplier power. Now, as automation becomes much more accessible to more companies, and you'll see Microsoft Azure, Google Cloud, all these great cloud providers are finding ways to basically provide automation and AI as a service. It's going to get much, much easier from here to apply the low-hanging fruit of artificial intelligence. As that happens, the number of commodity suppliers is going to increase while their size is going to decrease. It's just going to become easier to play the game. However, the number of critical suppliers, meaning those that are highly differentiated and do something very unique, they will contract while their size will increase. And a lot of that has to do, again, with proprietary data. It creates a winner-take-all environment for those unique suppliers. Andrew Ng once said, if you gave me all of the best data scientists in the world, but I did not have access to Google's data, I couldn't build a new Google. There's just no way. And the also thing you have to keep in mind is that it is very hard and expensive when you think about switching costs to change from unique suppliers, because those suppliers' services actually rely on your data, either by analyzing the historical data that you've had throughout your relationship, or by looking across their portfolio of clients and delivering meta-analysis that you can then benefit from. That's something that you can't get if you just uproot and switch. It goes beyond the cost of transferring your data from one cloud service to the other. The other thing that you've got to think about is buyer power. And within the context of buyer power, the main way that AI is influencing this is through algorithmic matching platforms, which again would be of something like an Amazon, it would be like an Airbnb. It's a service that basically uses algorithms to remove friction to make buyers and suppliers come together more easily. What this does, by aggregating the purchasing power in sort of one place, it does increase the number of customers that you have. That's a good thing, but it also makes it a lot easier for them to spread their spending across multiple vendors. It also makes price discovery much easier, leading to greater price sensitivity. Not so great. And the other thing is that, think about not to beat Amazon into the ground here again, but think about the product suggestions. It's very easy for competitive products to be surfaced to buyers, and the cost of a buyer switching to another platform is much lower because the platform actually owns that front-end customer experience. The friction of switching is basically taken away. So now let's think about the threat of new entry. We touched on this a little bit before, but as it becomes easier to use AI and requires a lot less technical expertise, it's going to be much easier to launch new businesses in the way that the cloud created what the economists called a Cambrian explosion of startups. So that's one thing to keep in mind. And those things also actually reduce the specialist knowledge that you need to run those businesses, but it increases actually for more specialist applications. So if you are doing something that's highly technical, say in the pharmaceutical industry, then that specialized knowledge is much, much more valuable. And proprietary data makes it almost impossible, as I was talking about that Andrew Ng example before, for new entrants to disrupt those specialized players. So if you're in the commodity space, good. If you're specialized, not so very good. Now, finally, the threat of substitution, to wrap this up very quickly. The threat of substitutes on that commodity long tail end of the business, that goes up. But it is, again, much harder to substitute if you have a specialized business that is grounded on proprietary data, especially on serving analysis of customer data back to their customers. But here is the thing. You might think, hey, I have one of these specialized businesses. I have a great proprietary data strategy. I'm safe. Here's the threat to you. It is the reframing of old problems using prediction and pattern recognition. And that can come out of nowhere. So think about Uber, to do another conference trope. They fixed the cab customer experience through algorithmically matching passengers and riders. So somebody can basically think about the problem that you're solving, reframe it a different way, and you could be caught by surprise. So what does all this mean when we come to the center of that 5 forces model? Far more markets than ever before are going to exhibit winner-take-all tendencies. Product quality in the long end of the curve is actually going to homogenize and improve. That's going to be great for customers. Maybe not so great if you're in that part of the business. But even though in the long end of the curve, you're going to see product quality homogenize and improve, that's still going to be left in the dust by those specialized and competitors. Now, switching costs are again going to plummet in that long end of the curve in the commodity business, but will skyrocket at the long end. And let me see if I have time for a tangent, a brief one. So there's one other thing that you've got to keep in mind about what AI is going to do more broadly, and it doesn't fit neatly within this 5 forces model, and I call it the unbundling of the firm. There was an economist who won the Nobel Prize called Ronald Coase for something that he called the theory of the firm. And he said, why do corporations form to begin with? And his insight that won him this prize was that it was because of transaction costs. So imagine you're at a group meeting, someone says, hey Bob, could you pass me the pencil? You don't say, sure, that'll be 50 cents, please. So what the corporation has done is effectively taken you out of the market. And allowed you to focus on cooperation, and it is better channeling cooperation that is what has allowed firms to form. What's happening because of AI is we're seeing transaction costs, both actual and non-monetary transaction costs, be lowered. And so you're seeing many firms rely much more heavily on contractors, outsourced organizations, TaskRabbit-like platforms that are meaning the corporation as we know it is starting to unbundle. I can't tell you if that's going to go in that final direction, but I can tell you it's a trend that we're seeing. So there's 2 big strategies to pursue. You can say, do I stay in that long end of the curve in the commodity space and just optimize and automate everything I can? Yeah, that is a strategy, and don't knock it, because there's a lot of companies that make a lot of money by playing that game. Or you can identify a valuable type of data that others don't have or are not using well, and find a way to build a virtuous feedback loop where more data equals more users equals more data equals more users. Now, typically this involves reducing frictions among established players through a platform approach, or reframing big problems through AI. But you must have a data strategy to do either. A strategy to continuously acquire the right data in the right format at high volume and low cost. All of those things are essential. You can't have 3 without the 4th. You have to continuously acquire, because again, these models are not steady state. They require constant updating. It has to be the right data. You have to make sure that it's, because corporations are swimming in data, but a lot of it's not the right. You need to figure out what is most applicable for your particular use case. It has to be in the right format. It has to be labeled. It has to be clean. You have to collect a lot of it, because supervised learning models require a great deal of data, and you can't pay out the nose for it or you're going to go broke. And you also need a strategy to do that, which basically, again, forms that virtuous feedback loop, and a strategy to monetize it that does not conflict with your collection approach. Our research indicates that just 11% of companies have such a strategy. So there's actually a lot of room to run here if you get out ahead of the curve. I'm going to skip past this because we're running a little bit short on time. But this is just a great data maturity model that we developed with Dr. Robert Plant of the University of Miami that looks at the various stages of data strategy, from point focus all the way up to ecosystem focus. Pin me down after the talk and we'll talk a little bit more about it. So we're going to take what that was slightly more complicated and longer-winded approach, and we're going to break it down into easy steps. Step one of your data strategy is first, and this is not targeted at you data scientists, this is targeted at C-level executives who maybe don't understand what you do for a living. So step one is define the problem. The way that you ask a question has a lot to do with the answers that you get. Think very carefully. Now, so imagine if Kodak had asked, if it was still in its prime today, what is the most efficient way that I can produce chemical film? Is there some new combination that's going to allow us to do it faster, better, and cheaper? Well, I'm sure there is, but that's not the right question. They were in the imaging business, not in the film business, and so that leads me to the next thing. Rethink, what business are you in? Also, kind of what business do you want to be in? Because Goodyear, for instance, is one of these great examples. They thought forever that they were in the tire business. Turns out they were in the business of getting things from point A to point B with as little cost as possible. And so they rolled out a service, which is basically tires as a service, that allowed their customers to better understand when things were going to break on their trucks, and to predict much more effectively what their maintenance costs would be, and of course to lower transportation costs. Now, bring in a cross-functional team. Now, the reason I have Eric Colson's picture here is because we did a great interview with him in issue 1, and I asked him, so where do you get your ideas? How do you take in business stakeholders and get them to think like data scientists so they can help formulate some of these problems? And he said, actually, we don't. Our best ideas come from our data scientists who we help to train up in the business, because it's just we found it very hard to train up non-technical executives to have that perspective. Respect. Disagree. So I totally get where he's coming from, but I don't think we should be leaving those executives in the dust, because there are certain insights that they have that might not occur. Like, for instance, I was chatting with a machine learning leader at one of the world's foremost firms I will not name, and the Porter's 5 forces model came up. Didn't know what it was. Not that that's a requirement for anybody to be successful in business, but there are just certain perspectives that business leaders have that data scientists, by virtue of different experiences, don't have. Step 2, what data do you have? What data is useful solving for the problem? Is it in the right formats? Is it clean? What's missing? What's missing here is the most important question. So think about if you're FedEx. You are trying to get deliveries to office buildings much faster. So you have a lot of data about your own operations. What else might you need? What data could you have that would allow you to shave a minute off that time? Maybe, for instance, it would be valuable for you to know where elevators are within the buildings, so that you can time your arrivals to coincide with that. So the other thing is, you need to get new data to plug those gaps of what you say is missing. I am shamelessly stealing this approach, which I'm going to plow through, on how to get new data from Jake Saper of Emergence Capital, who wrote a great article about this in issue 1. And he has a matrix of different data acquisition hacks, which are proprietary versus non-proprietary. That kind of makes sense. Aggregation, taking existing data that's already out there, but just putting it in one place, or creating net new data. So the first one is a non-proprietary aggregation approach, which is scraping. Think web crawler. It's very easy. You can do it with large volumes of data. You can do it again and again. The problem is that's not very proprietary. Somebody else can do it just as easily as you can. It can present legal issues, and it's hard to get that output data that's necessary to close the loop. You can also partner with existing firms or governments that have this data in an unstructured format, and you provide the talent and the know-how to make use of it. Tractable is one company that does that by partnering with insurance companies and others to improve the car accident repair process. You get closed input-output loops, which is important. That can give you a barrier to entry if it's an exclusive partnership. The problem is it's a lot of work, and you've got to be prepared for that. You can crowdsource this. To talk about Andrew Ng again, he gives a great example of some of his students that went out in fields and took pictures of cabbages to seed a data set for an agricultural tech business. Or you can do that through a platform like Mechanical Turk. This, by the way, is a great way to put labels on the data if you have an issue with that. Now, workflow first. This is a very interesting two-step model. The idea is that you build the mousetrap, and then you watch the people go through the mousetrap. You build something that is useful without machine learning, and then you use customer behavior on that platform to draw better inferences. The issue with that can be that it's very hard to get from step one to step two. Sometimes these things fail, and again, it can be difficult because all your customers need to agree to share their data, and some customers are very uncomfortable doing that. And here's the next level. This is my tag on to Jake's approach, which is platform strategy. Now, this is not a hack. This is a new business model. You can't dip your toe in the water. You have to commit. And the thing is that the best way to get a high volume of data at low cost is to get other people to create it for you for free. Now, that means you must fundamentally transition from being a maker and pusher of products and services to being an owner and organizer of ecosystems. We shouldn't think manufacturing line, we should think gardening. Now, that's a very different mindset. Now, what that means is it puts you in a winner-takes-all situation more frequently, because that's a hard advantage to overcome. But you also got to keep in mind, are other platforms already doing what I want? Because they've probably taken all. So, and as I said, this is not just a hack. This is something that you have to commit to it. There is an entire deep economic discipline built around platform economics, and they don't follow any of the traditional rules of industrial economics that you might have learned. And now the final step of your data strategy is monetize. There are a number of ways that you can monetize your data. You can increase user time spent through serving ads, use behavioral and other user data to serve more targeted ads for higher CPM, something we at Forbes think quite a great deal about, as you imagine. We could improve outcomes for end users and then get those end users to pay for it. Or you can find somebody else that cares about outcomes for those end users and get them to pay for it. In terms of a platform strategy, you're thinking about what is the money side of the platform versus what is the subsidized side of the platform. Or you could give the product away for free and monetize the data through another product or service entirely. There are actually a lot of efforts by Google, for instance. Think Google Classroom. That's completely given away for free. There is no revenue model except further on down the road tangentially. And of course, you could give the product away for free and sell that resulting data to a third party who cares about it, or use the data to create a platform ecosystem. This is not everything that there is, but the one thing that you have to keep in mind is that your monetization strategy cannot conflict with your collection strategy. So let's say you take that partnering approach and you partner with a university. The university is unlikely to want you to use their data to serve ads to their students. So that kills your business right there. So you've got to be that's an obvious way of a conflict. There's much less obvious conflicts. So some closing thoughts. Again, as I said at the opening of this talk, what I've just said will not be true forever. There are a lot of new approaches to machine learning that are reducing the amount of data needed to train and maintain models. That, ladies and gentlemen, is a very good thing, and in our mind is the future of this discipline. There are also a number of nascent initiatives, some of which we're talking about right now, of data pooling, which may reduce the centrality of proprietary data sets. Federated learning is one of the more interesting areas in this field, and if we can find better ways and better economic incentives to pool our data, this is going to be great for everybody. But this is not going to happen overnight. This is several years out. The same general structure that I've outlined is likely to persist. But the real question is this: what do you do? Now, you might think, first of all, the question is, do you even use AI for your business? You might not need to. Just because it's the latest buzzword does not mean that AI is going to be a panacea or even a band-aid for what ails your business. Certainly we believe, being biased somewhat, that it is applicable to a large swath of the world's companies, or can be used in some way, shape, or form. But you've got to think smart, you've got to ask the right questions, and you've got to know where you're going from a strategic context. Thank you so much.
And we have